So our sun is violent, okay? We live in the atmosphere of a giant star, and this is a dangerous place to be in many ways. A solar flare happens in a sunspot group, okay? The interior workings of the sun, that generates magnetic fields, and every so often these kind of pop up and come to the surface. It makes that bit of the sun a little bit darker, and we can see that as a sunspot. The way in which we see them using latest space observations adds more information to that. We can see the magnetic fields, we can see how complicated it is, we can look for shears and patterns that suggest this is a very stressed thing and it wants to give up the energy that's stored in there and explode. And if that happens, that is called a solar flare. The sun suddenly chucks out a whole lot of ultraviolet light, radiation, X-rays as well, even gamma rays in the big events. It takes 8 minutes for all of that stuff to travel towards the Earth, and it can pose real problems for satellites, for astronauts as well. But for auroras, that part isn't so relevant as what's associated with it, because the biggest flares, which we call the extreme category events, or Xclass flares, they're usually associated with coronal mass ejections. Now what that is a second part of the energy release, which instead of going into light and radiation and X-rays, it goes into producing a big bundle of magnetic field and wrapped up around usually about 1 billion tons of plasma. And that gets thrown out into the solar system. Now, chances are, if one of these things happens, it's not going to come our way. It could happen on the back of the sun, and we never see it. We get best views of them when they happen just as the sunspot group that's produced it is turning around the limb of the sun and then it goes off to the side. But every so often, instead of seeing one of these things in our telescopes going off to the side, you see something that looks like a ring, and it's growing. And that means that this thing is coming towards the Earth. When one of those hits us, it produces a kind of supercharged aurora. First of all, it usually comes with quite a punch. It takes 1 to 3 days to travel towards the Earth. The ones which come the quickest tend to have the biggest effect. And it kind of, first of all, it stirs up the Earth's magnetic field by that same process as the solar wind, but does it more efficiently. But there's another effect as well, which is called an auroral substorm. Again, if the magnetic field is pointing in the correct direction, then lots of energy starts to get transferred into the Earth's own magnetic field at the night side of the Earth. Somewhere around kind of where, for us on the ground turning underneath, it would be around midnight. The energy builds up until it just can't take anymore, and suddenly the Earth's magnetic field kind of snaps back, as if the coronal mass ejection had grabbed Earth's magnetic field, pulled it out like a rubber band, and let it go. That's called an auroral substorm. And for us, in terms of seeing auroras, it's good news, okay? Because those are the conditions that can bring it down so that it's overhead of us in Dundee. And those displays also tend to be the richest, the most dynamic ones that there are. They can fill with all sorts of kind of spirals and whirlpools almost in the sky overhead. It's a truly fantastic sight. The bad news that goes with that is the Earth's magnetic field getting jumbled up like that. While jumbling up magnetic field, stirring it, I said that creates electrical currents. Okay? The ones that happen in space and give us the auroras, those are very nice. But they can also get into power grids. In 1989, this happened in Canada, and a large number of Canadians were plunged into darkness in the middle of the winter. It's happened more recently in Sweden. It's also a concern for satellites, and airlines also often have to reroute their flights because of this type of space weather. And for that reason, well, the Aurora spotter kind of gets a free ride here, because governments are very interested in predicting these things, passing the information on to the companies that run this very important infrastructure, and they want to give them warning. And we can read those as well, which to us is, say, a piece of good news, while other people are reading it as bad news.